Okay, so the prosthetic limb project, it originated with a school in Alabama, Chickasaw High School. Um, they run this program called SKY, Skilled Knowledgeable Youth. And I haven't gotten all the details on it because that's never been my forte, right? They've apparently got a bunch of initiatives going. This prosthetic limb project being one of many awesome things that they're doing.
Sure.
Well worth emulating up here somewhere, but again, I'm just dipping a toe in. This is the first year I've ever really worked with them. So basically, Chickasaw, Alabama, they've been working with skilled knowledgeable youth, and this is called their Life Changer Initiative. And it makes sense. I mean, giving somebody who cannot walk a means to do so and a means to productively work and go to the grocery store and all the things that we just take for granted. That is a life changer. I will not argue with that title at all. Sometimes it's a very dubious. You make a statement like that and it's not true, but
Right.
I would say that this is literally the case. So basically, they have and I wish I was in my classroom right now because I've got the actual physical unit there. It's probably one, two, three, four, 1, 2, 3, 4, 5. It's probably 8 or 10 major pieces, and then a lot of nuts and bolts and hardware type items as well. The majority of which are 3D printed using high-tech plastics. So a lot of schools, I mean, a shocking number of schools, can't manufacture anything subtractively like the TMA membership would. So no mills, no lathes, nothing of that sort, but they do have 3D printers. So Chickasaw High School started this out, and they were 3D printing all the parts that they needed in their own building. And when it came to the metal parts, they were farming them out to a shop somewhere in Alabama, an actual for-profit shop, private enterprise.
Mm-hmm.
And basically, the program has been growing year on year, I gather. Brian Copes, the gentleman, the director of this at Chickasaw, is the person that I've been working with. And they've been seeing a lot of success and a lot of demand for these limbs once they're made. They not only design, I think the design came from outside. I don't know who designed it. I'm not too clear on that right now. But they go to southern Mexico, Central America, and they're fitting people with these limbs with high schoolers. But the demand, he had said his most recent trip, I believe it was to Honduras. They had 44 people trying to get limbs at their first stop of 4 that they were doing, and that would have cleaned them out for the entire trip. Like they would have been able to fit everybody there, but there would have been nothing for anybody else on any of the other legs of the journey. So the demand has gone up, and they were kind of at capacity. 3D printers don't move particularly fast. It takes hours and hours and hours to produce one part. If there's any problems, you're kind of stuck. So they got a bunch of other schools on board to produce the 3D printed parts. That's a little easier to pull off than it is the metalworking end of things. So Chickasaw was supplemented by the one I know that's also 3D printing parts is a school in Gulfport, Mississippi. But then it came to the metal parts, and they didn't have a good source for that. Enter the Harbor Freight Foundation. So Harbor Freight Tools for Schools is the owner of Harbor Freight. It's still again, there's one distinct owner, Eric Schmidt. He's a good guy, and he has a foundation designed to do good within the skilled trades and career and tech education. I happen to have won an award with them in 2018. We still meet. All the award recipients still get the opportunity to meet and interact on a regular basis. And so I met Brian Copes, and he's showing me this leg, and everybody else is looking at these 3D printed parts thinking, hey, maybe I could make those in my school. And I was doing the same thing in my head with the metal parts, because metalworking has always been Streamwood High School's forte. We're very good at it. I don't like bragging, but I have some top-notch talent at Streamwood High School, and they make impressive things. They do impressive work. So basically what wound up happening was they had identified a need to get the metal parts made by schools as well, in addition to the 3D printed parts, if only to save for cost and to bring in some more school participants, so that we're collaborating over a bigger chunk of the country. So Streamwood High School wound up doing 100 leg bone assemblies. It's 2 pieces. There's a central solid piece and then a tube that surrounds it. So we made a net total of 200 parts. And then the pivoting pins, like the things that you'd see in the knee and the ankle, they're much smaller. Those are being made by the high school in Candor, New York. A friend of mine over there decided to bring those on. So once we got the project, in other words, once we were greenlit by a skilled, knowledgeable youth to do this, they had some funding for materials. They were reluctant to, they have some funding. They don't have an unlimited budget, so they'd said, with the metal parts especially, let us know what you need for materials. But the first thing I did was I realized that the inner leg bone, the solid metal leg bone, I had material that was almost perfect for it, and it came from Auto Engineering in Carpentersville. TMA member. So he has since retired. I mean, very, very recently, but I reached out to Mr. John Lang. I reached out to him. I explained kind of what we were doing. And because what he had given me in the past was bar drops, bar ends. It's the scrap material that the machine can't process when they use a 12-foot bar. There's a small remainder, and that small remainder was what they had been giving me for classroom instruction. And I had said, hey, look, I've got a part that's almost perfect to what you had given me in the past. Can I get some more of them? Was kind of, like, I need 100. And they went above and beyond. They reconfigured their machines so their bars were a little shorter. They wouldn't work for the parts. So they gave me every bar end they had in terms of that would meet the minimum length I needed. And then they gave me, they made up the entire difference. So they gave me the entire job lot of parts. They had to buy new bars to do it.
Wow.
But again, credit to them. And this is not just John. This is the entire Auto staff is currently there. They recognized that this was going to be doing some good too. So the inner leg bones were entirely funded by Auto Engineering. The outer leg bones, because they were just a very standard tubing that's more common to the plumbing industry. And I don't know plumbers. I don't have plumbers on my advisory board. For the other tubing, for the outer tubes, we sought a local vendor, and we spent some money there just because we could get it quick, and we knew what we needed. So basically, that's how we got the materials. I cut the kids loose on the process. I sort of talked them through it. We had one copy of the outer leg bone and one copy of the inner leg bone delivered to us from Chickasaw, Alabama. And, they showed us what we were looking at, and, slide them around to the students and, oh, hey, can we do this? And, it was a great conversation where they wanted to know what they could get away with adding, changing, modifying. We had a great discussion because the prints that they sent to us, and I'm not meaning to be disrespectful to anybody, but Chickasaw sent us untoleranced prints. So there were dimensions on them, but there were no limitations as to how big or how small you could make things. And anybody in the TMA knows that that's probably not the best way to do business. So we had to self-tolerance, if that makes any sense. We had to say, well, we've got this metal here, we've got this metal here. One needs to fit inside the other. What kind of tolerance limits should we place on the inner leg bone versus the outer leg bone? And then after that, it came to not a realization. I didn't even have to suggest it to the students, but we could have made them on manual machines, but we'd still be doing it. We have Streamwood has a lot of manual machines. We could definitely set up individual workstations and do this in a very sort of traditional manual way. But the students were aware pretty much from the get-go that we needed to make CNC machines do as much of this as possible. So I had my advanced class set up the fixturing, work out the tool paths, take the models that were in SolidWorks, shift them over to Fusion 360, cam them up. It really was their show. I did very very little. I got the materials. I made sure they had the cutters and the tools and the parts that they needed. But when it come to actually designing the fixturing, setting it up and running it, I ran a few just to say I did, but I almost any student that touched that equipment did 10 times what I did.
So I can just imagine my thought, so many thoughts and questions. It had to change their passion for this, and so they would understand exactly how important manufacturing is in making things are when they knew what it was going to be for, and it was a positive social contribution to do. I mean,
yeah, this is wholly unique. We've never done a project like this where there was this big giving back component, as it were. We do projects all the time for the TMA's precision manufacturing competition. The kids love it. They love the competitive aspect of, hey, I did this better than so and so at a different school. And that has always been a strong motivator. As a matter of fact, that's one of my best motivators year on year with the students is the PMC competition, because they make practical parts and practical tools, things like that they enjoy, but they also get to they get a ranking. They get judged, and again, you get that student that they might not be the best student in English class, but they are they are the best in the state at, or the third in the state at making a hammer out of steel, for example.
Absolutely. And every achievement is worthwhile for a person's value and their perception of themselves.
This project was unique in that it had the social end of things. It was not a difficult sell because the first class I brought on was my advanced class, because I knew without them the fixturing and the tool paths and everything else would have fallen to me, and that didn't strike me as a good idea. So I approached them first. But then after that, I had, in my own head, I'm like, we could keep this just within the advanced class and just have them handle the whole project. But there was a lot that could have been done by my lower classes, by my freshman and sophomore classes. So I pitched it to them as well. And there was not a class that was like, oh no, that's stupid. Everybody was just like, yes, we're in. I never had an issue finding, like we had to run 100 of these. This is a repetitive thing where load a bar, cycle start, load a bar, cycle start. And I never had a problem finding a volunteer for that, because everybody knew that it was a little different. They were doing some good, and it was fulfilling, and it was a really refreshing change of pace. I wish I had more things like this, because again, the extra motivator is really.
How many students of yours were involved in the project overall?
I involved 3 classes of students.
Okay.
And that net total is about 70 kids.
Okay. At different levels, she said.
Different levels. So about 55 of them were new learners, year one. We want to call them first year students, and then the remainder were either 2-year or 3-year veterans of our program.
So they used not only engineering, where they really did. If you're having to determine tolerance, you're talking about engineering at that point, right? I mean, the skills that they used was, you had a blueprint, but I mean, it was still pretty vague.
I don't want to play up the engineering side of it, because number one, the entire project had already been designed by people that were not us and were far wiser than us. So. And secondly, again, we tweaked it for manufacturability, yes, but unfortunately, engineering gets bandied around too much within our area. I understand that you can earn a very viable career teaching engineers, and I do teach a fair few of them. Okay, but one of the reasons I took this operation on was to show the production side of things.
Got it. So what other skills? I started with engineering. I'll skip over that one. So tell me the other specific skills that you used in the process that we could list.
3D solid modeling. Applying tolerances was huge, because I treated that as a discrete thing. It was more quality control than it was redesign, because we didn't want to fundamentally change the parts. All we just wanted to know was how, at what point do we consider the part scrap, like based on, how, in other words, we needed a working tolerance so that we could actually make the parts and know whether or not we were doing a good job. So I would call that more quality control than anything else. CAM, computer aided manufacturing, because that went in hand with a 3D solid design. Machine setup, fixture design. Yeah, I would stop there, because we could put this on the list. It's underrated. It had to be done. Deburring.
Okay.
I have a feeling, because if Chickasaw is amenable to us producing a lot of these for them year on year, I would like the opportunity to do it again. But I would most definitely work with my advanced class again to revise our strategy to include as much deburring as possible on the CNC machine, because it was good that I had lots of hands on the less skilled level, because when it came to, okay, we have 200 parts, the outer leg bones, we had 100 outer leg bones that had 30 holes drilled in them, and every hole needed to be deburred. So 3,000 holes that we had to hand deburr. And if we could make the CNC machine do that, we would be coming out a lot better, certainly. But again, we didn't anticipate that on round one. So I think next year, if we do this, one of the big ones we're going to be doing is process improvement.
So all of these skills, and there, it's a pretty wise thing in this particular generation. I hate to put them into generations, but the motivation of being socially beneficial is a big motivation for the younger age groups. That's just a fact. I mean, it's out there, but whether or not you intended to do so, you tapped into that as a motivation. Do you have offhand any ideas of comments you heard from your students as you were working on this that really kind of touched your mind?
I wouldn't be able to do a direct quote. Unfortunately, a lot of my students are not really chatty.
That's so typical.
But that's the thing. And I teach manufacturing. Okay, I don't teach business. I don't teach speech communications. A lot of my students, I'm lucky if I get 3 or 4 words a day out of them.
They keep their heads down and do their job, right?
But it's their actions that have meaning. You know what I mean? This project ran without a hitch for the entire time it needed to. I didn't have anybody grouse or complain. Oh, you're making me, I don't want to do that. It was like, hey, I need somebody on this CNC machine. We've got this operation going. I need somebody over here. We're doing this. Hey, if you've got some spare time, can you deburr those? There was never any gripes. There was never any pushback. Everybody was just like, oh, done. It would just happen. There were no issues, no arguments. So I think that spoke volumes. Again, I don't have a lot of students that are real expressive.
How long did the project take from getting involved to sending those parts off?
I found out about the project in July, just after the 4th of July, like a week after the 4th of July. But obviously we didn't really, I learned about the opportunities there, brought them back to the school. We didn't officially get a green light to manufacture from Chickasaw until, I think it was right around Halloween, October 31st-ish.
Yeah, that's starting in November then, really.
Yeah. The production run was pretty much a November thing.
Okay.
My goal was I wanted them done before they were charged with, through one of their sponsors, one of the people providing some of the money for this, who's actually, again, flying down to these countries and fitting people up and whatnot. They had provided funds, but one of the things they wanted was, their goal was 100 legs by the end of the school year.
You're way ahead. 6 months ahead.
But if you look at it, if you think about the logistics and the supply chain end of it, they can't finish legs without our components and we're not the end of the road.
Oh, I got you.
There's some
Okay.
high
Yeah.
strength epoxy that has to be bonding parts together. They've got to fit everything out. There's a lot of extra steps after the parts leave us. So these were all boxed and shipped to Chickasaw High School, but that
Wow.
doesn't mean they're ready to go. They can't just take them out of the box and fit them to somebody right there, right then. There's a bunch of other steps that have to occur. So I wanted to make sure that they had time for that.
Can you get a photo of those parts being inserted or assembled into the other? Have
I
you asked
can
them?
ask Brian Copes to see if he's got something.
It'd be awesome to see, like, to be able to follow, even just a little bit, the transition.
I've got, so for example, I've got the print that they originally gave us, which is a great 3D view. Looks really good. I think one of the Instagram photos I had was just of the print by itself.
So I can use that.
You can of course use that.
Okay.
I have, again, they gave me one copy of all the different parts so that we could see how we could understand how everything went together. And so I've got that, and I've got it where we could section it out and actually pull it out. So like you could see our bits and you could see how they connect to the other ones, almost like a Lego assembly sheet or a IKEA furniture assembly kind of thing. I genuinely, I haven't seen the assembly yet. I don't know what they do or how they do it. So,
well, I would like to. I could say this is a project in process, but the part that you've done is finished. You've moved it on. We probably would like to see what you can do, to wrap it up. I would love to publicize that as much as I can. So, would you be comfortable with me promoting Sky as an organization?
I would let me put you in touch with Mr. Brian Copes.
Okay.
It's his baby. So I just want to make sure, because Sky is also out of Alabama. So they're not local to us by any stretch. I think it's absolutely awesome that he's gotten buy-in. I think it's awesome that he was willing to share this project that has such a profound social impact with so many other schools. Right. Because again, I know that, like, for example, I don't have the 3D printers to make the other parts in the machine. There's one school in Washington State that's making these parts out of rubber. It's like water jet cut rubber that, again, I don't have the equipment to do those either. And just the fact that he was able to broaden this network so that everybody can collaborate on something this powerful is awesome, but it is still fundamentally Alabama's
Which
thing.
is exactly the way the chair you're sitting in was made. Everybody did something different, and you rarely do you find, but that's such an incredibly widespread lesson for these kids, just to appreciate what it takes to do anything, but